Good afternoon friends and welcome to another session of Parijat sir classes, and today what we are going to discuss is another topic of the mathematics, which is called the continuity of a function. So today we will be discussing the continuity of a function. This is a class 12 mathematics going on. So this is the full continuity I have discussed here, and I can guarantee you nothing outside this is going to come from continuity for any board exams or any other competitive exams. So my request is, please keep following the Parijat sir classes. As you can see here, Parijat sir classes, and like, share and subscribe. Definitely please do, so that I can get motivated for making more and more videos for you. So please like, share and subscribe. So without wasting any further time and to increase the length of the video, so let us get started with the chapter, which is continuity. Okay, so as you can see, continuity at a point. A function is said to be continuous at a point, at any point x equal to a, if its domain, what is domain of its domain? If, now watch, please watch here, we will be telling that a function will be continuous at any point x equal to a can be any point, if the left hand continuity of the function, I will show you what is this, is equal to the right hand continuity of the function, right hand limit, or we can say, and is equal to the function at that value, the value of the function at that particular point. So without giving you any further misconception, so let's get started. What are actually this? We have to check the left hand limit of the function at the point given, we have to check the right hand limit of the function at the point given, and we have to find the value of the function at that particular point. So let us move ahead. So here, first question, they are telling that test the continuity of the function fx. What is our function? Our function is two types, one is this and one is this, and we have to test it at x is equal to 0, x equal to 0. So let us see what is happening here. Now, as we all know modulus, what is modulus of any? Suppose I write minus 2, it will be taken as plus 2. So modulus means anything will become plus. That means this x can be either negative or positive. It can be either negative or positive, and if I give a modulus here, I will get x, and if I give a modulus here, I will get x. So basically this modulus has two formats. One is a negative value can happen, one is a positive value can happen. So let us check the left hand limit of this function. So left hand limit at x is equal to 0. So see, so left hand limit means less than 0, so 0 minus, okay, and right hand limit means more than 0, right hand limit will be little bit more than 0. So let us first check left hand 0. So less than 0 is x will become negative. Less than 0 means the values of x will be taken as negative. So mod x is becoming minus x, and this becomes minus 1. That means the left hand limit is coming as minus 1. Similarly, right hand limit means more than 0. So more than 0 means positive. So mod x will become positive values. So x by x, which is 1. So as you can see, the left hand limit and the right hand limit do not match each other. That means the function will not be continuous at x is equal to 0. It will be discontinuous at x equal to 0. Okay. Further, we can see that x equal to 0, at x equal to 0, the value is given 1, the value is given 1. So that means we can see, as I already told you, that the condition for the continuity of a function should be that the left hand limit value should be equal to the right hand limit value, should be equal to the value at that particular point. So see, left hand value, it came left hand value came 0, left hand value came -1, right hand value came 1. That means they are not equal, so we can directly tell it is discontinuous. Also at x equal to 0, as you can see, the value came 1. That means we cannot tell all the three conditions are satisfied, so it is a discontinuous function. Clear? Let's see the next one. So here it's given fx equal to x sine 1 by x when x not equal to 0. That means this condition is valid when x is less than 0 or x is greater than 0. We can check about this. Okay, and we have to check at x equal to 0. We have to check at x equal to 0. So let's see. Left hand limit. So x tends to less than 0, so little bit less than 0, so 0 minus x sine 1 by x. So if I put in place of x, if I put 0, so it's coming 0 into sine 1 by x will be what? Sine of any function, remember it will always oscillate between +1 and -1. That means the function will always take values like this. That means between +1 and -1. So this function is an oscillating function between +1 and -1. So whatever value we get, but we have to do into 0. That means the answer of this is coming 0. So left hand limit is 0. Similarly, right hand limit will also be 0. And at x equal to 0, that means at f0 we are getting the value 0. So all the three conditions of the continuity are satisfied. That means left hand limit is equal to the right hand limit is equal to the value of the function at that point at f0. All the three values are coming the same. So we can tell that the function is continuous at x is equal to 0. We can tell it is continuous at x equal to 0. Let's see the next. So the function given to us fx is equal to sine x by x. This is the function given to us. Okay, sine x by x plus cos x. This is one function. And when can you choose this function? When this function, we can choose this when x is not equal to 0. That means for less than 0 and for greater than 0 we can choose this function. And at x equal to 0 the value of the function is given as 2. So let's check the continuity at x equal to 0. So the left hand limit, as you can see, the left hand limit x tends to 0 minus, so little bit less than 0 of this function. So if it is little bit less than 0, so I told you that we have to choose this function. Okay, and similarly for greater than 0 also I will choose this function. Clear? So left hand limit, as you can see, we are testing for the left hand limit. Clear? So this is the left hand limit we are testing. Then we will test the right hand limit, and then we will test at x equal to 0 the value. Okay, so let's see. First of all, so sine x by x, so we have separated the application of the limit here. And please remember, this is a formula. Limit x tends to 0, sine x by x is 1. Please remember it. And limit x tends to 0 cos x, this is also a formula. It is also 1. So answer is 2. So these two are formulas. Limit x tends to 0, sine x by x is 1. Limit x tends to 0, cos x is also 1. Okay. Now right hand limit, again we are taking limit x tends to 0, sine x by x, which will give me 1. And limit x tends to 0, cos x will also be 1. 1 plus 1 is 2. And at x equal to 0, answer is given 2. At x equal to 0, answer is given 2. That means I can tell that the left hand limit, the right hand limit, and at x equal to 2, the value of all the three has come equal, that means it is a continuous function. It is a continuous function. Clear? Let's test the next one. Okay. So the next sum says that examine the continuity of the function at x equal to pi by 2. We have to test it. Okay. So this is for less than equal to pi by 2. That means I can test it for x less than pi by 2 and x greater than pi by 2. I will choose this function. I will choose this function. Clear? And at pi by 2 I will choose this function. Okay. So first of all, let us see the left hand limit, which is, so I have chosen x less than pi by 2, less than, so pi by 2 minus means less than pi by 2. So I have taken this function. Okay. So see how to write limit h tends to 0. H tends to 0. Okay. Now how to write this? Please watch here. If I take, please watch the step how I am writing it. Okay. Now here this is x tends to pi by 2, correct? Now please watch here. If I take pi by 2 minus x as h, so if x is tending to pi by 2, isn't h tends to 0? Please note here, if x is tending to pi by 2, my h should tend to 0. Clear? And in place of x, in place of pi by 2 minus x, I will put h, and in place of x I will put pi by 2 minus h. So please note these steps how I am putting it. So in place of x I am putting pi by 2 minus h, and this I have taken as h. And if x is tending to pi by 2, if x is tending to pi by 2, h will tend to 0. So if x tends to pi by 2, h tends to 0. So ultimately it comes limit h tends to 0. So upper one becomes sine h by h, and this is a formula which gives me 1. Because limit x tends to 0, sine x by x is 1. Similarly, for the right hand limit, same function I have to choose. So same way, x tends to pi by 2, so h will tends to 0, and this will become pi by 2 plus h. Clear? Pi by 2 plus, because I have taken pi by 2 minus x as h. So our x will be pi by 2 minus h. This will be pi by 2 minus h. I'm sorry. This will be pi by 2 minus, x will be pi by 2 minus h, sorry. Okay, which is sine h, and this is becoming and pi by 2 minus h is actually h, so this will not be there. So again it comes limit h tends to 0, sine h by h, which is 1. And at x equal to pi by 2, already they have given the value of the function is 1. That means you can see that the left hand limit value, right hand limit value, and at x equal to pi by 2 all are giving us 1. That means it is continuous at x equal to pi by 2. It is continuous at x equal to pi by 2. Clear? So let's get started with the next sum. So next sum says this is our function e to the power 1 by x minus 1 by e to the power 1 by x plus 1 when x is less than 0 or when x is greater than 0. Okay, and we have to test the continuity at x equal to 0. So let us take left hand limit. So for left hand limit I will choose this function. Okay, now if x tends to 0, now see, so h tends to 0. If x is tending to 0, h is tending to also 0. So see, please see how to write it. E to the power in place of x. So in place of x we are writing 0 minus h. So if x tends to 0, h tends to 0. Please note these steps. These are important steps. You have to keep a note of this. If x is tending to 0, then how to write it? If x tends to 0, h tends to 0. And last sum also I showed you how to convert the limit. So let's see. So in place of x I am writing 0 minus h. This is 0 minus h, which is e to the power minus 1 by h, and here is minus 1 by h. So this I am writing as this, please watch it, and this I am writing as this, please watch it. Okay, so now how to write this sum? Now please watch one thing. Limit x tends to 0, e to the power x minus 1 by x is always equal to 1. Okay, so what I can write it is, if I can write it like this, please watch one thing, that is 1 minus e to the power x, or e to the power x minus 1, same way I can write it like this. So this is 1 minute, let me check this. So here, as you can see, that if I put here h as 0, so please watch here, if I put here h as 0, so 1 by 0 will be infinity, 1 by 0 will be infinity. If I put here, please watch here one thing, let me show you this calculation. Please watch the calculation here. Okay, it is given 1 by e to the power 1 by h. Okay, and x tends to 0, h tends to 0. That means if I put here in place of h, if I put 0, it is coming how much? E to the power 1 by 0, and 1 by 0 is infinity. So e to the power infinity is infinity, and 1 by infinity is 0. Okay, so this gives you 0, this gives you 0. That means it is minus 1 by 1, and which is minus 1. Similarly, this. Okay, so here limit x tends to 0 means h tends to 0. I can, here it is, I have taken 0 minus h as x. So if x is tending to 0, so I can tell h will also tend to 0. So here we can write, in place of x I am writing 0 plus h, and this h tends to 0, h tends to 0. Again here we can write it like this. Please watch here, we are dividing by e to the power 1 by h up and down. We are dividing by e to the power 1 by h. So this will become 1, this will become 1 by e to the power 1 by h, this will become 1, this will become 1 by e to the power 1 by h. Now again put h as 0, so this will become 0, this will become 0, 1 by 1 is 1, and since the left hand limit is not equal to the right hand limit, so we can tell it is discontinuous at x equal to 0. Clear? Okay friends, let's see the next sum. Discuss the continuity of the function at x equal to half. That means for less than, so you can see here, for less than half we will choose this equation. For equal to half we will choose this, and for more than half we will choose this. So let's see. Left hand limit x tends to half minus. Okay, so let us take half minus x as h. So if x is tending to half, h will tend to 0. So here we are writing, if x is tending to half, h will tend to 0, and in place of x I am putting half minus h. Okay, So it comes out to be h, and if I put the value of 0, I am getting 0. Similarly for the right hand limit, this, so in place of, if x is tending to half, h tends to 0. So in place of x, I am putting half plus h. Okay, so I have taken half plus h for this. For this case, I have taken x half plus h. So if x is x equal to half plus h, isn't it? So see here, x means half plus h. So that means if from here we are getting 1 minus h, now putting the value of h as 0, so we are getting 1. That means we can see that the left hand limit is not equal to the right hand limit. So I can tell it is discontinuous at x equal to half. Discontinuous at x equal to half. Clear? Next, discuss the continuity of the function at x equal to 2. Okay, so we have to test it at x equal to 2. So let us check it at x equal to 2. So the functions are given. For less than 2, I will choose this function. For equal to or more than 2, I will choose this function. So let's see the left hand limit where I have to choose less than 2. So I have to choose this function, and I have taken let x, let 2 minus x. Please watch here. I have taken let 2 minus x is equal to h. So if x tends to 2, h tends to 0. So here we have taken if x tends to 2, h tends to 0. In place of x, I have put 2 minus h. So this comes out to be h, and the value comes 0. For the right hand limit, again in place of x, I am putting 2 plus h. So x tends to 2 means h tends to 0. So we are getting 4 plus h, and if I put the value of h as 0, I am getting 4. So we can see that the left hand limit is not equal to the right hand limit, and so we can see that it is coming discontinuous at x equal to 2. So it's coming discontinuous at x equal to 2. Clear? Okay friends, so let's see the next sum. So the next sum says that this is the fx given. Now we have to test at x equal to 1. So for less than 1, I will choose this function. For equal to 1 also I will choose this function, and for greater than 1 I will choose this function. So let's see. This is the left hand limit, so I have to choose this. And so let us take x minus, so I have taken, because it's taken 1, so let us take x minus 1 as h. So if x tends to 1, h tends to 0. So let's see. If x tends to 1, h tends to 0. In place of x, I will put 1 minus h. In place of x, I will put 1 minus h. Okay. I've taken 1 plus h, 1 minus h. We have taken 1 minus h as 1 minus x as h. Okay. So friends, here just I have taken it like this. You can take this also, no problem. You can take it like this, no problem. So anyhow you can take it, it's not the problem at all. We have taken 1 minus x as h. So if x tends to 1, h tends to 0. So x will be 1 minus h. So it comes, now putting the value of h as 0 here, we get only 1. Similarly in this, x will be taken as 1 plus h. We have taken x for this, we have taken x. Same thing we can do. Basically there is no use of taking it like this. So we could have taken, For this part also it's no problem. We have taken it, let x equal to 1 plus h. So if x tends to 1, h tends to 0. This we have taken it for this particular sum. So if x tends to 1, h tends to 0. In place of x, I have taken 1 plus h. Okay. Now taking this common, we are opening this and we are getting, now keep putting the value of h as 0. So this goes, this goes, this goes, it is only 1. Okay. And at x equal to 1, we have to choose this value. Now put the value of x as 1. We get it 1. So we can easily see that the left hand limit, the right hand limit, and at x equal to 1, all the values are coming same. So it is continuous at x equal to 1. It is continuous at x equal to 1. Clear? Okay. So next, see, show that the function this is continuous at x equal to 0. So first of all, when we choose the left hand limit, we will choose left hand limit means less than 0. So x will be taken as negative. So see how we are writing this part. X is taken as negative. So this is our equation. And we have assumed let x minus 0 is equal to h. So if x tends to 0, h tends to 0. So here we are writing, okay, this. So putting the value of h, we are getting 0. Similarly, for this right hand limit, that means x is more than 0. X is more than 0 means positive. So mod x will become positive x. The mod x will become positive x. So here we get it. And now in place of x, I am putting 0 plus h and put limit h tends to 0. We are getting as 0. Similarly, at x equal to 0, at x equal to 0, the value will become what? 2 into 0 minus 0, which is 0. That means we can see that the left hand limit, the right hand limit, and at x equal to 0 values are same. So it is continuous at x equal to 0. It is continuous at x equal to 0. Clear? Let's see the next sum. The next sum says, here we have got the functions. Please watch. Discuss the continuity of the function. This is the whole function at x equal to 1 and at x equal to 2. So first we'll check it for x equal to 1. So please watch here. If I take x less than 1, if I choose x less than 1, so this will become negative, this part will become negative, this part will become negative. Okay, so that means this is our function and this is our function if I choose x less than 1. Similarly, if I choose x greater than equal to 2, so this part will become positive, this part will become positive, this part will become positive. So we will write like this. And if x is between 1 and 2, more than 1 but less than 2, this will become positive and this will become negative. This will become negative. So this is our function. Okay, so now it will be easy for us now to decide when to choose what. So we are testing at x equal to 1. We are testing at x equal to 1. So let's see. Limit, left hand limit, limit x tends to 1. Okay, so this will be taken as negative, negative, function becomes this, functions becomes this, and so friend, let's see here in this sum. So first of all, when we, as you can see that if it is less than 1, we are choosing this equation. and so it comes out to be like this. Now, so let us take x. So we have taken here as x as 1 minus h. So if x tends to 1, h tends to 0. So here we have taken, if x tends to 1, h tends to 0. In place of x we are putting 1 minus h, and this comes, and let us put h as 0. So this is the value of the function. For the right hand limit we have to choose which is more than 1. So more than 1 we have to choose this value. So we have taken this function, and as you can see that x cuts out, this is plus 1. So if I put x tends to 1 in this, the answer will come 1. Similarly, at x equal to 1, I told you that at x equal to 1, see this is the equal to sign given, so we have to choose again this function. That means it comes out to be 1, and then it is 1. So that means since the left hand limit and the right hand limit and at x equal to 1 all are coming same, so it is continuous at x equal to 1. Now let us test it at x equal to 2. So as you can see that if I take greater than 2, first is less than 2. If I take less than 2, the first one will become positive, the second one will become negative. Please watch here, the second one I will take as negative. So it comes out to be this. So when we test at left hand limit at x tends to 2, we are getting the answer as 1. Similarly for the right hand limit, that means more than 2. So both the parts will become positive. More than 2, if this is more than 2, this is positive. If this is more than 2, this is positive. So this comes out to be this. And now let us take x as 2 plus h. Okay, so if x tends to 2, h tends to 0. So then this comes out to be this. Putting the value of h as 0, we get this. Now why we are taking 2 plus h, why we are taking 2 minus h, why we are taking 2 plus h or 2 minus h? Please watch here, we are always writing limit x tends to 2 plus more than 2. That's why we will write let x equal to 2 plus h. If we are testing limit x tends to 2 minus, so we will take x as 2 minus h. Please note all these things. Okay, at x equal to 2 we don't have to take anything, so that this is positive, so this comes out to be, putting the value of x as 2, we are getting this as 1. Now see, the left hand limit, the right hand limit, and at x equal to 2 all are same. That means it is continuous at x equal to 2. Now similarly, find k if the function fx is continuous at x equal to 3. Okay, so this is our function given. That means for x less than 3 we will choose this, and for x greater than 3 we will choose this, and for x equal to 3 we will choose this. So let's check less than 3. Since it is less than 3, I told you let x equal tends to 3 minus h. So if x tends to 3, h tends to 0. So here we are taking, first simplifying this, we are getting this. Now here we will put x as 3 minus h. So h tends to 0, it comes out to be this. Putting the value of h, we get this. At x equal to 3 we are getting 3. Okay, now because they told it is a continuous function. So what is our condition? Our condition is left hand limit should be equal to the right hand limit should be equal to at x equal to 3. So using this part we can tell that 6 should be equal to k, so k equal to 6. Next, see friends, the next one. Find lambda so that the function is continuous at x equal to 1, at x equal to minus 1, continuous. So this is our function. That means for x less than 1 and for x greater than 1 I will choose this function. So let us test it at left hand limit. Left hand limit, x tends to 1 minus. So let x tends to 1 minus h. So if x tends to 1, h tends to 0. So putting this, first let us midterm this. So we are getting this part, this cuts out this. So now limit x tends to 1 minus, at this we'll put x as 1 minus h, so h will be 0, h tends to 0, x means 1 minus h, okay, minus 3. So now here we get minus 4 and this. Similarly at x equal to minus 1 they have given it is lambda, and since the function is continuous, so left hand limit equal to the right hand limit equal to at x equal to minus 1. So using this part we get lambda is equal to minus 4. Let's see the next sum. Find k so that the function is continuous at x equal to 0. Find k so that the function is continuous at x equal to 0. So see, that means for x less than 0 I will choose this, for x greater than 0 I will choose this function, and at x equal to 0 I will choose this function. So left hand limit, that means I have to choose at x less than 0. So first of all, 1 minus cos 2x is 2 sine square x, 2 cuts, it's this. Now since we are testing at less than 0, so I will let x tends to 0 minus h, okay. So if x tends to 0, h will tend to also 0. So x tends to 0 means h tends to 0. So there is a sine square x. Now x means 0 minus h, 0 minus h. So this becomes this, okay. And we can write it as, so this minus becomes plus sine square limit. Please remember one thing, the formula is limit x tends to 0 sine x by x, this is equal to 1. So putting this, so this is 1, this becomes 1, so 1 square is 1. So at limit h tends to 0 we are getting 1. Similarly at x equal to 0 they have given the value as k, and because the function is continuous we always know that left hand limit equal to the right hand limit equal to at x equal to 0. So using these two conditions we are getting that k is equal to 1. Find a if the function is continuous at x equal to 2. So you are testing at x equal to 2. So let's see. For less than 2 they told that take this function. For equal to 2 they told take this function. For greater than 2 they told take this function. Okay. So let's test it at limit x, the left hand limit. So that means x tends to 2 minus. So let x tends to 2 minus h, if excuse me, if x tends to 2, h tends to 0. So using this, in place of x we are taking 2 minus h. So here we got, and now putting the value of 0 in h, we are getting this is the answer. And at x equal to 2, what is the value given? A. So because it is a continuous function, so left hand limit should be equal to the value at x equal to this. So the answer will come a equal to 3. Okay friends, if the function fx is continuous at x equal to 0, they are telling that the function is continuous at x equal to 0, find the value of k. Okay, the function is given, this is the function when x not equal to 0, that means for greater than 0 and less than 0 I will choose this function, and for equal to 0 I will choose this function. So any one of them let us choose the left hand limit. That means limit x tends to 0 minus, I will choose this function. As I told you that limit, let x tends to 0 minus h. So if x tends to 0, h tends to 0. So putting x tends to 0, h tends to 0, in place of x I am putting 0 minus h. So it comes out to be this. Now here we are writing log 1 minus ah by minus h. So we are separating the limit part. We are separating the two limits, and please remember here limit x tends to 0, log x plus 1 plus x by x is 1. So this is my x part. So here I have to make it ah. So I put here minus a. Okay, so I have to adjust with an a here. Similarly, I have to make it bh. It is bh, so I have to make it bh. So that means I have to write minus b here. So I have to adjust with a minus b here. I have to adjust with a minus b here, if you want to write minus b. So minus and minus becomes plus. So this becomes 1, this becomes 1. So that is plus a, and that is minus b, plus b. So left hand limit gives me a plus b, and at x equal to 0 we get k. So k is equal to a plus b. You have to remember this formula. This is an important formula. Similarly, let's see the next sum. Find the value of a if fx is continuous at x equal to 0. Fx is continuous at x equal to 0. So at x less than 0 and x greater than 0, I will choose this function. At x equal to 0, I will choose this function. So let us take the less than 0 part. Left hand limit x tends to 0 minus. So let x tends to 0 minus. So then here, so as you can see friends, here we'll put it at x tends to 0 minus h. So if x tends to 0, h tends to 0. So h tends to 0, in place of x I am putting 0 minus h, and this comes out to be this. So we can write it like this, but we have to match this angle. So I have to put here an a, and that has to be adjusted with a square because it's a square. So then this, already I told you, limit x tends to 0, sine h by h gives you, sine x by x gives you 1. So this gives out to be a square. And at x equal to 0, they have given the value of 1. Because it is continuous, So left hand limit and this value at x0 should be same. So this is the value of a. Let's see the next sum, friends. So this is the function given, and there are three types of things given here. That is, if x, they are telling that fx is continuous at x equal to 1. Okay, for greater than 1 I will choose this function, for less than 1 I will choose this function, and at equal to 1 I will choose this function. Find the value of a and b. So first of all, let us take the left hand limit. So I told you that let x tends to, I have to check it at x equal to 1, so 1 minus h. So if x tends to 1, h tends to 1. So if x tends to 1, h tends to 0. H tends to 0. In place of x I will put 1 minus h, and we are getting this. Now putting the value of h, we are getting this answer. Similarly, the right hand limit. So let x tends to 1 plus h. If x tends to 1, h tends to 0. Okay, so x tends to 1 means h tends to 0, and putting this in place of x, 1 plus h, solving it. So we are getting, and putting the value of h as 0, we are getting this answer. At x equal to 1, they have already given 11. Now because it is a continuous function, so we know left hand limit should be equal to the right hand limit, should be equal to at x equal to 1. That means 5a minus 2b should be 11, and 3a minus plus b will be 11. Solving these two, we get the values of a as 3 and 2. This is how we will be finding it. Let's see the next sum. So this is a function given, 1 minus cos 4x by x square if x is less than 0. For greater than 0 I will choose this function, and at x equal to 0 I will choose this function. Clear? So let's see. They are telling find the value of a if fx is continuous at x equal to 0. So let us check at limit, left hand limit, that is 0 minus. So for the left hand limit, let x tends to 0 minus h. So if x tends to 0, h tends to 0. So putting this, x tends to 0, h tends to 0, in place of x I will put 0 minus h. It comes out to be like this. 1 minus cos 4h is 2 sine square 2h. Please note these. So here the angle with the sine is 2h. So here I have to write here as 4 and adjust with a 4. Adjust with a 4. So 4 into 2 is 8, and now this I can write it like this. And already I told you limit x tends to 0, sine x by x is 1. So this will be 1. This part will be 1. Square is 1 into 8, 8. Now come to the right hand limit. In the right hand limit, what we will check? Let x tends to 0 plus h. If x tends to 0, h tends to 0. So putting it here, x tends to 0, h tends to 0. In place of x I am putting 0 plus h. So it comes out to be this. Now rationalizing the denominator with the opposite sign. This is a minus b into a plus b, which is a square minus b square. So this cuts out, and then root h will cut out. So it comes out to be this. Now putting the value of h as 0, we get this. So because it is a continuous function, So the left hand limit should be equal to right hand limit, should be equal to the value at x equal to 0. So that at x equal to 0 it is a, so a should be 8. Now let us see, find f0, if the function is given like this, is continuous at x equal to 0. It is continuous at x is equal to 0. So let us check how to write this. This is our sum. Now what we are doing is we are trying to first of all see there are few formulas you have to be aware. Limit x tends to 0, a to the power x minus 1 by x is log EA. This is one formula you have to remember. Second formula, x tends to 0, sin x by x 1. Third formula you have to remember, limit x tends to 0, log 1 plus x by x is 1. So using these three formulas we will solve the sum. So first of all, see, it is looking like the first formula, a to the power x minus 1, but there is an x missing. This x should be missing, so it comes inside the cube. That means I have to adjust with x cube. Similarly, sin x4, x by 4, so there should be an angle x by 4 at the bottom. So see, we have adjusted this angle. Similarly, log 1 plus x square by 3, this part should be at the bottom, so I have adjusted with this. So it x by 4 and x square by 3 becomes x cube by 12. It becomes x cube by 12, and there is an x cube, so only it remains as 1 by 12 at the bottom, that is 12. Okay, x square and x, this will cut, so this is 1 by 12 at the bottom, goes up. Now this becomes 1, this becomes log e4 whole cube, this becomes 1, this part is 1, this part is 1, okay, and this part becomes log e4 cube into 12. So this okay. Now they are telling, now what is the value of f0? Now see here, putting the limit, we are checking that there is f0, that means that there is no x left here, so we can't put x as 0, so this will directly be the value of f0 because there is no x remaining here, so we can't put x as 0. That means this will be the value of the f0. Let's see the next sum. fx is given this for x less than 4 and greater than 4. Okay, show that fx is discontinuous at x equal to 4. So let's check. For less than 4, this will become minus, this is plus, so it comes out to be minus 1. For greater than 4, this will be positive, so this is plus 1, and at x equal to 4 they have given the value of 0. So because it is continuous, so I can tell that left hand limit is not equal to the right hand limit, and also at x equal to 4 it is not coming equal, so it is discontinuous at x equal to 4. Similarly, let us check the discontinuity of this function. Sin 2x by x I will take only when x is 0, less than 0. X plus 2 I will choose only when x is greater than or equal to 0. And we have to check the continuity at x equal to 0. So let us take the left hand limit where I will test at less than 0. So let x tends to 0 minus h. So if x tends to 0, h will tend to 0. So here x tends to 0, h tends to 0. First of all, see, the angle with sine is 2x, so here should be 2x. So I have to adjust with 2. This 2 goes out. So limit x tends to 0, sine 2x by, already formula we know, limit x tends to 0, sine x by x is coming 1. So this is 1. So answer is 2. Right hand limit, we have to take this. Okay, putting the value of x as 0, we get 2. At 0, putting the value at x equal to 0, we get 2. Now since left hand limit equal to right hand limit equal to at x equal to 0, so it is a continuous function. It is a continuous function. So friends, let's take the next part. Discuss the continuity of the function. This is the function. So for less than 0, for greater than 0, I will choose this function, and for equal to 0, I will choose this function. So left hand limit x tends to 0 minus, it will become less than 0 means this is negative. So answer is coming minus 1. Right hand limit, I will take this as plus x. So answer is coming plus 1. And at x equal to 0, they have given 0. So left hand limit is not equal to right hand limit, is not at x equal to 0. So it is discontinuous at x equal to 0. Next, we have to check the continuity of the function at x equal to 0. So this is one function less than 0, and for greater than or equal to 0, I will choose this function. So left hand limit x less than 0, I will choose this function, putting the value of x, I am getting minus 1. For right hand limit, I will choose this function, putting the value of x as 0, I am getting 1. And at x equal to 0, I will choose this function, and putting the value of 0, I am getting 1. So because left hand limit is not equal to right hand limit, so the function is discontinuous. Please watch one thing. There are certain important things here. That is, any constant function will be continuous everywhere. Means at all x belongs to real number. So it is continuous everywhere. Similarly, identity function is continuous everywhere. Polynomial function is continuous everywhere. Rational function is continuous at every point in its domain. These you have to remember. Modulus function is continuous everywhere. Exponential function continuous everywhere. Tangent function is continuous in its domain. Cosecant function continuous in its domain. Sine function continuous everywhere. Cos function continuous everywhere. Logarithmic function continuous in its domain. Secant function continuous in its domain. Cotangent function is continuous in its domain, and sine inverse function is continuous in this. So basically we see that these type of functions, what we are seeing, okay, they are generally continuous. These functions, they are generally taken to be at continuous functions. Okay, generally taken to be continuous functions. So how will it help us? So let's check. Show that the function this is our function, is continuous everywhere. So first of all, you see that here we can have two type of function. One is this function, we call it gx, and one is the modulus function. There are two types of functions. So in this function there are again two parts. One is a polynomial function and one is a modulus function. We know polynomial function is continuous everywhere. We know modulus function is continuous everywhere. So gx is continuous everywhere. Similarly, this is a mod function. So modulus function is continuous everywhere. Now both these functions are interlinked. How? h o gx. So h of gx, which is giving me this function. Now because each and every function of this is continuous, so I can tell that this function, which is fx, is also continuous everywhere, right? This is the application of that chart. This is the application of that chart. Next is, here they have given, so see there are two functions. One is this function, which we call it as gx, and one is a square root function, we call it hx. Now in this part we have got two parts. One is a continuous modulus function, which is we know continuous everywhere. Polynomial function is continuous everywhere, so gx is continuous everywhere. Similarly, square root function is continuous everywhere, so HOGX will be h of gx, which is fx, which is my ultimate function fx. This is actually what? H of gx. Okay, so since both h and gx are continuous functions, so fx is continuous function everywhere. Determine the value of the constant k so that the function this is again continuous. So for x less than or equal to 2, I will take this function. So left hand limit x less than 2 minus. So let x tends to 2 minus h. So if x tends to 2, h tends to 0. So x tends to 2 means h tends to 0. In place of x, I will put 2 minus h whole square, which is this. Now put the value of h as 0. We get 4k. Right hand limit will take the function as 3. So the answer is 3. And because it is continuous, so left hand limit should be equal to right hand limit. So the answer is k equal to 3 by 4. Let's see the next function. Find m. Find m. Fx is given as this. For x less than 0, I will choose this. For greater than or equal to 0, I will choose this. So left hand limit less than 0. So let x equal to 0 minus h. If x tends to 0, h tends to 0. So in place of x, I will put 0 minus h. Solve it. Now put the value of h. So we get the answer as 0. Similarly, for the right hand limit, I will choose this. Okay. Let x equal to 0 plus h. If x tends to 0, h tends to 0. So here I will take, since the left hand limit is not equal to the right hand limit, so I can tell it is discontinuous for all values of m. Okay. So let's see the next one. Fx is given as this. If it is less than or equal to 3, I will choose this function. If it is greater than 3, I will choose this function. Okay, so let's check at 3. So left hand limit less than 3, answer is given as 1. More than 3, right hand limit we will apply here. in place of x put 3. So this is the value at right hand limit, and because it is continuous, so left hand limit should be equal to the right hand limit. So this is the first equation. Similarly, it is continuous at 5 also, so less than 5 I will choose this equation, and more than 5 I will choose this equation. So less than 5, putting the value of 5, I am getting this, and more than 5 I am getting 7. So because it is continuous, so this should be equal. Now solving it, we are getting a as 3 and b as -8. So friends, this is all about the continuity of the function, and I hope you have understood it. So my request is, if you have understood it, please follow them properly and try to solve it in a very slow manner along with me. Okay, try to understand how I am solving them, and please keep solving along with me so that you can get the confidence of this particular chapter. So please solve along with me to know it in a very proper and confident manner. Okay, don't just keep watching it, pause and please solve the sums along with me. So thank you for watching it. Please keep watching Parijat sir classes. So please watching Parijat sir classes till we meet again for the next class. Thank you.